Hi everyone! Welcome to Thunder Bay's first ever virtual Canada Day. For a full list of events, make sure to visit thunderbay.ca/Canada Day. My name's Caitlin and I'm with Science North, and today I've got all kinds of exciting science experiments that have to do with Canada Day and the Canada Day parties that I have. So I hope you're excited because there might even be experiments that have fire in them. So stay tuned and keep your eyes peeled. One of the reasons I love Canada so much is that many of us get 4 distinct seasons, even snow. And we get animals that are able to survive this cold because of their adaptations. And one of those animals has a jaw this big, a polar bear. Now, polar bears are able to swim in very, very cold waters because of their fur, but also because of something else, because of the fat underneath their skin. And some animals have this, and it's called blubber. So you can see here, we're gonna do an experiment to show you how insulating blubber, or the fat underneath these animals' skin, works. So in front of me, you can see I've got a thermal camera. So what we're gonna do is I've got a bucket of really cold water right here. Now, first things first, we're gonna see how warm my hands are. So you can see how they're red in the middle. That means warm. So red is warm, blue is cold. So my fingertips are a little bit cold. My nose is always cold. So our experiment is I'm gonna put one hand with no protection inside of the cold water and one hand with our blubber glove inside the water, and we're gonna see which one keeps my hands warm. Okay, are you ready? So here we go. Putting them in the bucket, and we're gonna count to 10, and we'll fast forward you through this, okay? 1,
2, 3, 4, 5, 6, 7, 8, 9, 10.
We'll do an extra 5 seconds just to make my hands hurt a little bit. Okay. So it's only been about 15 seconds. I had one hand in the blubber glove, one hand not in the blubber glove. Can you see that? So one of my hands, this one right here, is almost completely blue. That's the one that didn't have any protection. And then my hand that was in the blubber glove is still warm. So this is amazing. This is an experiment you can even try at home if you make a blubber glove. I used some Crisco food shortening, which is basically like lard, and I made a glove out of it, and it protected me from that cold the very same way that it does for polar bears. And that's one of the major reasons I love Canada. We have all these amazing animals. All right, so we learned a little bit about polar bears and how they can survive the cold and the snow. So I'm gonna do an experiment that has to do with snow, but I need you to keep an eye on the glass or the cup that I put water into, okay? So I've got my cup here. Keep an eye on this. Might be a trick. And I'm gonna pour it into one of these cups. Are you ready? Okay. So keep an eye on the cup you think the water is in. I'm gonna spin them around. Keep an eye on the screen. Are you ready? So you don't lose the cup with the water. Maybe the water's not in that one. Oh, not in that one. Okay, so most of you at home have a guess in your head of which cup the water went into. Is it this one? Is it this one? Or is it this one? Okay, keep that in your head. So you probably don't think it's in this one. So I'd be willing to pour it on the table. It's not in that one. Okay, cup number 2, do you think it's in this one? There's only one way to find out. Not in that one either. So the water has to be in this cup, right? There's only one way to find out. What is that? I made snow. So I played a little bit of trick on you. The water wasn't in any cup. It got absorbed by this really cool kind of super absorbent polymer. Now this is called instant snow. So I've got a little bit of this powder here. And each one of these tiny little powders can absorb almost 400 times its size. Okay, so I'm gonna pour a little bit of water in here. And we're gonna watch how it expands and grows and turns into what looks like snow. You can still see it growing. Now this stuff is really, really cool, and you've probably come in contact with it before. So this was invented by NASA, and it was needed because astronauts actually wear diapers. And this is the stuff inside of diapers that absorbs all that waste that we create. So if you have a little brother or sister at home, this might be found inside of their diaper, which is really neat. So this is a super absorbent polymer. It's kind of like a chemical or a little tiny ball that absorbs moisture. Okay. One of my favorite things to do in the summertime, especially on Canada Day, is invite friends over and have a little bit of a party. Usually we go on the trampoline, we go swimming at the lake, we have all kinds of fun. Now, this year's a little bit different, everybody's social distancing, but I have a really good story of one summer when I had a really good Canada Day party. So, usually when I have a Canada Day party, I like to make sure that my guests have something to drink. So my first friend, right here, asked for a cup of water, so I gave them a cup of water. Now my second friend, they were feeling a little fun. They wanted some fruit punch, so I said, sure thing, of course, I've got fruit punch. Whoa, that's pretty neat. Now my first friend said, hey, I didn't even know fruit punch was an option. Can I have some of that? I said, of course. We just got to put everything back into my container, and we can have some fruit punch. So now, friend number one got some fruit punch. Friend number two got some fruit punch. Now by the time I got to friend number three, they were real thirsty. And all they really wanted was water. What just happened? Isn't that a cool experiment? I played a little bit of a trick on you, and I used something called a chemical indicator. So let's zoom out and I'll talk a little bit about it. Now you're probably wondering, what just happened? I actually used chemistry to play a trick on you. So what happened was, in my very first cup that I was pouring out of, I had water and a little bit of something else called a chemical indicator. And this chemical indicator is called phenolphthalein. And chemical indicators basically indicate something or tell you when something is present. So my chemical indicator tells us if an acid or a base is present. So let me go on. In my first glass, I didn't have anything inside at all. So I was just pouring my clear solution inside of a clear glass, and it was clear. In my second glass, it turned pink like fruit punch. It wasn't actually fruit punch. And that's because I had a little bit of bleach, just a couple of drops in the bottom of this cup, so you couldn't even see it. So when I poured my clear indicator into this cup, it reacted with bleach, which is actually a base, which is the opposite of an acid. And when phenolphthalein comes in contact with a base like bleach, it changes colors, which is really neat. So it turned that bright, bright pink. Now, my last cup, it changed back to clear. And that's because in the bottom of this cup, I had a couple of drops of vinegar. And vinegar is actually an acid, so it's the opposite of a base. So when we mix in all of these together, it kind of neutralizes it, and it goes back to being an acid. So watch, if I pour everything into this container, it goes back to clear. Isn't that neat? So I used a little bit of chemistry to fool you. Okay, I've showed you how I love to have Canada Day parties and parties in the summer where I entertain my friends and bring them drinks, and then I play tricks on them. But I never showed you how I deliver these drinks, and I use a really special tray. Have you ever seen anything like this before? To deliver my drinks. So what I like to do is I'll just take one of these cups we just used in the last experiment. I like to put it right in the middle of my tray, and then as I'm delivering it to my friends, I actually spin it around. Are you ready? We're gonna do this together. And my glass doesn't fall off. Did you see that? So my friends really enjoy this trick. But how does it work? Let's talk about it. For this experiment to work, we're using a special type of physics called centripetal force. It's kind of like when you're on a roller coaster that goes in a big circle and you feel like you're trapped and you can't move your body. It works the exact same way. So when we put our glass on top of our kind of holder here, and we spin it in a big circle, we're creating centripetal force, and the cup is always being attracted to the middle where I'm holding the end of the rope. Now, you might say, hey, Caitlin, how come gravity isn't pulling our water down when it's upside down? Well, it's because it's in continuous motion in a circle. So the cup is going towards the center because of gravity, and it's moving in a circle, so all of those forces of physics work together, and I can flip my cup around, which is a really, really cool experiment. Our next experiment has to do with gases, and there can be a lot of gases at Canada Day parties, but not that kind of gas. Today we're going to be talking about gases in general. So when you think of a gas is actually something that takes up space. So when you're breathing out air, which is a gas, it's taking up space in the room, even though you can't see it. So if I tried to squish my hands together, that weird noise you get is the gas escaping. So gas takes up space. So let's do a little experiment to prove that. Now, first and foremost, we're going to make an experiment that releases gas. So you've probably done this at home. You put some baking soda and vinegar together in a container, and you make a bubbly mess. Now this makes a bubbly mess because it's creating gas. So you can see all those bubbles. That is carbon dioxide, a gas being created. Now I'm going to show you a different way that I can make carbon dioxide, and it's using something called an Alka-Seltzer or an antacid. Now when you mix an antacid, which is sometimes your parents have these if their tummy hurts, if you mix this with water, it also creates a gas. So watch this. Can you see all those bubbles being created? Now, right now, the gases that I've produced are leaving these containers, but I want to prove to you that they take up space. So what I'm going to do is I'm going to use this tiny little container here. I'm going to add an Alka-Seltzer inside. I'm going to add water, and then I'm going to seal the top with a balloon, and we're going to watch to see what happens. So here we go. Add a little bit of water. Okay. Add my balloon. Now let's watch. Turn it around so you can see. Can you see that? My balloon is inflating. So I'm going to put my goggles on in case this pops. But you can see that the gas being produced is all being held inside of this balloon, which is amazing. And you could try this experiment at home. You just can use a water bottle and then put a balloon on top after. So now that we know gases take up space, I've got a really fun experiment for us. I've got our experiment set up. So you'll notice I've got all these little containers, the same kind that we use for our balloon experiment. Look how big that is. But this time what we're going to do is we're going to add water and our Alka-Seltzer, but we're going to seal the top. So we know that our kind of Alka-Seltzer and water makes this much gas, but if that gas can't escape, what's going to happen? Well, it's going to go pow and explode. But I have a question for you, and you're going to make a hypothesis. Do you think the container that has more Alka-Seltzer, so a full piece like this, will go faster or explode quicker than that one that has less Alka-Seltzer? Well, there's only one way to find out. I want you to think of your answer right now, and we're going to try this experiment. So I'm going to add the same amount of water to each of these. I'm going to close the lid so you can see I've got a full piece, a little bit less than a full, almost a half, a quarter, and a tiny little chunk at the end there. We're going to seal these up and see what happens. So I'm going to put my safety goggles on. Let's start it up. I'm going to add a little bit of water. Perfect. Perfect. Make sure they're even. Okay. Now I'm going to add the lids. So how to do this, I'm just going to close it and push down, but they're not going to react yet because they're stuck to the top. So I got to be careful that they don't touch the water or they'll start to make gases without me wanting them to. Okay, are you ready? We're going to shake them and spin them. Oh, we lost our seal on that one. That's okay. We're going to watch the other one. So this one's out of play. Let's watch the other ones. Which one do you think is going to go off first? I think it's going to be this side. Okay, so it happened to be this one. Interesting. Let's watch what happens next. Oh, I can see these ones don't have a very good seal. Oh, did you see how powerful that was? This one had so much more Alka-Seltzer in it, created a bigger explosion. Okay, next. I don't know what's gonna be next. I'm a little nervous. This one. I'm gonna make holes in the roof. Okay, that's okay. Science is a little messy sometimes. Who's next? And anything coming from our last guy with our least amount of water? I'm a little nervous. Let's wait. Let's see how long it takes. Well, I think I give up. I don't think this one's gonna go off. I can see that the gases are being created, but I don't think it's enough to be able to pop the lid. So what happened here? Well, we had our second one go off first, and that's probably because it had a really good seal. But for the most part, our Alka-Seltzer and tablets on this side of the tray went off first, and that's because they had more substrate in the reaction, and they were way more powerful. So this first one that went off kind of was a slow dud, and then these ones were insane, crazy fast, and probably made a hole in the roof, which is really neat. So from this experiment, we learned more substrate or more stuff that we put in a reaction, the faster it goes, and in this case, the more powerful. I've been talking about my Canada Day party this whole time, but I forgot to mention that I love to do party tricks. So if you've ever had a summer party, usually you have people in your backyard, you're playing all kinds of yard games, but my favorite trick is to do something called a Vortex Cannon. So I'm gonna be able to knock these cups over using a vortex ring. Can you believe it? So you're gonna have to keep your eyes peeled because this is gonna go by really quick. Are you ready? Oh, this way. How does this work? Let's talk about it. How did I knock over those cups? Well, I created a vortex ring, and it's actually invisible because it's just circulating air. So if I hit my own face with it, you can see that my hair is going all over the place, but you can't see kind of the shape that the air is creating. But I have a way to change that. I'll be right back. Okay, are you ready? Can you see that? This is what the air coming out of my vortex cannon looks like. It's actually a circle. And that's happening because the air is actually circulating on top of itself, and filling outwards because of this kind of motion that I'm doing. Let's watch. So it's this really cool circle. Now, you can actually make a mini version like this at home, and I'm gonna explain exactly how to do that. To make your own vortex cannon at home, you'll need a couple of things. You'll need a cup, you'll need some saran wrap, some tape, and scissors or something to cut a hole with. Now for this first part, you'll probably want an adult to help you because making this hole can be tough. So the first thing you need to do is cut a hole in the bottom of your cup and then cut out a little circle. Kind of like that. So next, what you're gonna do is you're gonna take your saran wrap and you're gonna cover the end, the big part, with your saran wrap. And then you're going to tape it with your tape. You can also use an elastic to hold it on, but I like tape. And that's it. You have a mini air cannon, and if you look, you can feel it. Now you can even go bigger if you want. So for example, I made one here out of a mini plastic garbage can and an old shower curtain. Or you can even make one out of a giant garbage can, cut a hole in the bottom the same way, tape a shower curtain to the other end, and you'll be able to blast your parents for the rest of the summer, which will be really fun. Now, you notice that I used fog in the last clip in order for you to see those circles. Now you might be thinking, hey, I can go to the campfire and use smoke to do the same thing, but smoke and fog are different things. So fog is more like evaporated water, whereas smoke is the aftermath of a fire. So it has that kind of darker look to it. But nonetheless, you can still have lots of fun with this and annoy your parents all day long. It's time for elephant's toothpaste. And this is one of my favorite experiments to do, especially at my Canada Day parties. Now, to make elephant's toothpaste happen, which if some of you know about it, it's a bubbly mess, I need a couple of ingredients. And I need specific amounts of each of these ingredients. It's kind of like when you bake a cake. So I like to bake muffins on Canada Day, and I need certain ingredients. And if I miss some, like eggs, the muffins don't turn out right. Same thing for this experiment. So my very first ingredient that I need is soap, which is right here. And this is a super special type of soap. You can't get it anywhere else. Just kidding. It's just regular soap. And the reason we have this is so that we can capture the gas that we're creating from the other two ingredients that we're going to add. So the next ingredient we're going to add, I'm going to add my glove on because this is 30% hydrogen peroxide. Now, you might have heard of hydrogen peroxide. Sometimes when you get a cut, your parents might put it on there to help you out, but the stuff at home is 3%. This is 30%, which is really, really concentrated. So if I were to stick my hand in there, I would get a chemical burn. So I'm going to use my glove and pour a little bit into this container, like so, and nothing is happening. And that's because I'm missing a full ingredient, which is our most important one in my opinion, and it's our catalyst. Now, a catalyst in chemistry basically fast forwards a reaction, because right now we don't see a lot happening. We need a catalyst to make everything kind of work. Our catalyst today is potassium iodide, and I'm going to take a little scoop of this, and as soon as I add this into our container, it's going to react with this hydrogen peroxide, create a lot of gas, and that's going to get captured in our bubbles. But this reaction is exothermic, which means it's hot, which you'll notice I've got my thermal camera set up here. I've got nice warm hands, and you're going to be able to see how hot this container right here gets. Okay, are you ready? So let's pour our last ingredient in here. And we get a bubbly mess. Okay, look at my thermal camera. Can you see that heat? That is a lot of heat. So let's turn that out a little bit more. Now, that was kind of hard to see on our thermal camera. So what I think we should do is do it one more time, but in a different shape container. So this container has kind of a thinner mouth. It's an Erlenmeyer flask. Now, do you think the reaction is going to go a little bit different because I have a different shape? Make a hypothesis, which is basically like a guess. Now for this, I'm going to add my soap again. Going to add some hydrogen peroxide with my glove to protect my hand. Perfect. And I'm going to add my scoop of my catalyst. Now this time, I'm going to add a little bit of red because it's Canada Day and we want to be festive. Okay, ready? Now keep an eye on my thermal camera. Let's make sure it's in the right spot. Perfect. Okay. Move it over just a little. 3, 2, 1. Did you see that? Look at that heat. Can you see that steam coming off? You can see it on my hand. So let's move the thermal camera down a little bit. Look at that heat. That is hot. That is bright red. Now, if I stuck my hand in this foam right now, which it looks like it's pretty fun, I would get a burn because of the heat and because of the chemicals, so I'm definitely not going to do that. Now, that was really neat and all. We got to see it on the thermal camera. Look how hot that is. Really hot red. But at Science North, we like to do things a little bit bigger. So I think we should do it one more time, but in a bigger container. So give me a second. I'm going to grab us a large container. Aha! Okay, let's do it one more time here. I'm going to stick this right in between. Now, if we're going to do it in a bigger container, which we can see on the thermal camera there, we're going to need more ingredients, right? If I make a bigger cake, I need more ingredients. So in this case, lots of our soap, and then a lot more hydrogen peroxide. A little more, a little more. There we go. And finally, our potassium iodide, which I'm just going to pour right in because I want to make a big mess and I'm going to have to clean it anyways. Oh wait, we need our food coloring because this is a Canadian special. Let's put our food coloring all around. Perfect. And let's pour in our potassium iodide. Ready? 5, 4, 3, 2. Can you see that? Look at my thermal camera. Look how hot this is. Now, this is called elephant's toothpaste, and I'm not sure why, because an elephant really wouldn't want to use this on his teeth, and you'd probably get some burns, but it's still called elephant's toothpaste. It's an exothermic foamy reaction. Look at that. Look how hot that is on the thermal camera. Bright red. And it's a fun party trick I like to do on Canada Day. Wasn't that fun? When it comes to us Canadians, we definitely like to be loud and make noise, especially at hockey games and sporting events and on Canada Day when we're celebrating watching the fireworks. So I have an experiment to show you how to be even louder, which I'm sure your parents will love. And this is something you can do at home too. So all you'll need is a can or a cup, and it can be any size, and all you have to do is cut a hole in the bottom and attach a string like I have here. So I just tied a knot in the string, put it through. You might need a parent's help to cut a hole in the bottom. And then you actually have a noise maker. So let's show you how this works. All you need to do is wet your fingers and pull down. You have to squeeze really tight, and you get a funny noise. It almost sounds like a fart, which is funny. Now, depending on the size of your can, you're gonna get a different sound. So let's try the second one. That one's really loud, which is great. And then finally, this one is pretty big. This is a coffee tin, and I have a different string too, so you can test out different things. That one's really loud and tinny. Now, why does this work? Well, it has to do with sound. So sound is actually a vibration. So right now when I'm talking, my vocal cords are vibrating the air coming out of my mouth, and it's going through the air, and when it hits someone's ear, it's vibrating the inner kind of bones and cochlea inside of your ear. That way we can hear it. So what would happen if I touch this without wetting my hands? Let's try the bottom here because the top's wet. You don't get any sound, and that's because you're not causing a vibration. When you get your hands wet, you're causing friction like that, and it's kind of tugging and creating vibrations that travel and are pretty loud depending on the size. Now the can acts like an amplifier. So if you've ever seen a speaker, or when you're trying to talk really loud, you talk like this, it amplifies that sound to make it really loud. So you can make one of these, head outside, and make lots and lots of noise for Canada Day. Something me and my family always do in the summertime, especially on Canada Day, is head out to the beach for a nice sunny day by the water. Now, one of our favorite activities, especially on Canada Day, is to bring a beach ball and play around with it. Now, something I've always said is I can make a beach ball levitate, and no one ever believes me. But I can actually show you that right now because I have the technology that I need. So I'm gonna use this big beast. And what I'm gonna do is I'm gonna make the beach ball levitate by placing it on top and turning my leaf blower on. So let's watch what that looks like. Did you see that? I can make the beach ball go right on top of my head. You might be wondering, okay, yes, of course the leaf blower can hold my beach ball up because it's using the force of air upwards, but what's pulling our ball down? Gravity. Now you'd think when the ball starts to angle over my head that it would fall down, but there's another force in play here, and it's called Bernoulli's principle. So in reality, when the ball is on top of the leaf blower, there's air that's blowing all the way from all angles around the ball. And some of them are in high pressure, some of them are in low pressure. So those differences in pressure kind of hold the ball in place so that there's air coming from both sides, hugging it in nice and tight. So when you push it over on an angle, it's still holding it in. Isn't that magical? That's the power of air. Now, you can try this at home if you've got a leaf blower and a ball, or you can try it scaled down if you've got a hair dryer and a ping pong ball or a styrofoam ball. You just put your ping pong ball on the end of the hair dryer, turn it on, and you'll be able to see that it kind of hovers in place, and you can turn it side to side without it falling out, which is really neat. Now, it's time for one more experiment with my favorite leaf blower. So let's move on. For this next leaf blower experiment, we've got to go back to Newton's laws, and one of those says, for every action, there's an equal and opposite reaction. So basically, when you push on something, it pushes back. Now that doesn't give you kind of an okay for when you push someone that they can push you back, but anything that we touch kind of pushes back. So for example, if I touch this globe here, it actually is pushing back on me. And I can show you that using this leaf blower. So when I push on the leaf blower, the air is pushing one way, and it's actually forcing the leaf blower the other way. I'm actually just holding it in place. So what I'm gonna do is stand on this spinner here and turn my leaf blower on, and we're gonna see what happens. So I'll take my mic off. Ready? Woo! That was close. Okay, so why did that happen? Well, the leaf blower air was pushing one way when I was holding it out, forcing me to go the other way. And this is Newton's law in action. Now, this is something you can do at home too with a lot of protective equipment on. If you have a skateboard and a leaf blower, I think you'd be able to get around by sticking it on the back and turning it on, because the air would be pushing one way, which would cause you to go the other way. Isn't that fun? One of my absolute favorite things to do in the summer, especially on Canada Day, is to sit outside at nighttime and watch fireworks because of all the different colors that they create. But it got me wondering, how do they get all those colors? You've got blues, reds, greens, a mix of all of these, and they all go off at once. Well, I've got an experiment here to explain it, and it has to do with the exact same reason you can change the color of your fire with those little packets that you get at the store. Okay, so after a little bit of digging, I figured out that the reason fireworks can change color is the same way that those little fire packs you get at the store can change the color of your fire. So I'm going to use a bunch of different kind of substances here to try to change the color of fire. Now, if I want to start a fire, the very first thing I need is fuel. And my fuel here today is called methanol, and I've chosen this because it burns clear. Now, usually when you light something like a match or a lighter, it has a bright yellow flame, but I don't want my flame to have color. I want it to be clear. So this will be our control in our first container to show us what just our fuel looks like with nothing else in it. Next, I have stump remover, potassium iodide, borax, calcium chloride, and table salt. And I'm gonna mix each of these with a little bit of fuel or methanol, and then I'm gonna light it on fire and see if we can get different colors from each of these. So let's fast forward. I'm gonna add my methanol to each of these, and then we'll set them on fire. Okay, we're ready. So I'm gonna shut the lights off, and then we're gonna light these up. Are you ready? Put my protective equipment on. I've got my fire extinguisher ready, just in case. Remember, don't try this at home. Okay, let's give these a second. Can you see that? We've got blue, purple, green, and more of an orangey color at the end. This is amazing. Let's zoom you in and show you what it looks like a little bit closer. So the blue in our stump remover is from the copper that's present, and that burns blue. We've got potassium in our second solution, and that burns purple. We have a little bit of barium in our third one, and that burns green. And then our last two have calcium and sodium, and those burn orange. Changing the color of our fire was really, really fun. So fun, in fact, I've got another fire experiment for us. This time we're gonna make a fire tornado. So you'll notice I have this really cool looking thing in front of me, which is basically a garbage can on a Lazy Susan. And I'm going to make a fire tornado by kind of saturating this sponge with fuel, which in this case is lighter fluid. And I'm using this because it burns bright yellow, and I wanna be able to see our flame. So when I stick it back in here and light it up and start to turn it, it's gonna get oxygen from all angles because of the spin, and the fire is gonna go upwards like a tornado. And fire tornadoes actually happen in real life when you have a forest fire and there's big gusts of wind that kind of oxygenate the bottom of the fire and send it upwards. You get them that go almost 3 stories high, which is amazing. So let's get this started. Okay, to make a fire tornado, what we need to do is take this sponge that I have at the bottom of my basically garbage can on a Lazy Susan, and I'm gonna soak it with lighter fluid. And lighter fluid, like I said, burns bright orange, so we'll be able to see it. And I'm gonna put this back on the bottom. I'm gonna light it on fire and spin it, and we're gonna get a fire tornado. And fire tornadoes actually happen in real life when you have forest fires and big gusts of wind that kind of oxygenate the bottom and it sends it upwards. So let's shut our lights off, put our safety equipment on, make sure we've got our fire extinguisher ready, and see what happens. Okay, we've got a good flame now. We've just got to turn it. Can you see that? This is incredible. So this is a fire tornado. We're getting oxygen going from all angles because we're spinning it, and it gets sent upwards to the sky. Now we know how a fire tornado works. We're going to do one more experiment, this time with our thermal camera right in front of our fire tornado. So you can see my hands are nice and warm. You're gonna be able to see the heat coming off of this fire tornado, and I'll even move our thermal camera upwards and you'll be able to see just how high that heat goes. So I've got my protective equipment ready. Don't try this at home, and let's light it up. Okay, so first off, you can see the heat right off the bat. Let's give it a spin. Beautiful. Now if I push this upwards, you should be able to see just how high that heat goes. Look at that. Hot, hot heat. Now, this should be a reminder to everyone to make sure you're safe around fire, especially campfires in the summer. So if you're having a campfire, be sure that someone's around that knows what they're doing, and make sure you're with an adult. Okay, I've got one more fire experiment for us because everyone loves fire experiments. This time I'm going to use a different fuel, and this is called butane, and it's actually a gas. And a gas is something we talked about earlier. It's floating around us, it's in particles. And I want to be able to hold on to this gas so I can set my hand on fire, which sounds scary. And again, I'm trained to do this. So how exactly can I hold on to a gas? You can't really grab it, you can't hold on to it. So what we're gonna do is we're gonna use bubbles. So we're gonna trap our gas in bubbles, I'm gonna hold on to it and then set it on fire. So for this experiment, what I have is a bowl of cold water, and what I'm gonna do is pour some of my soap in the bottom, like this. And then all I have to do is take my butane, flip it upside down, and push it on the bottom of this bowl, and it's gonna create bubbles. So listen. Can you hear that? So now we've got all kinds of bubbles on the bottom of our container, and I'll show you in a second. But first, I like my arm hair, so I'm gonna put on my gloves, and I'm gonna put on my shield, and I'm gonna shut off the lights so we can see a little bit better. So let that clear up. Okay, so I'm going to light my match, hold on to the bubbles, and set it up. Did you see that? So all of that butane that was trapped inside of those bubbles lit up really quick, and as soon as it got ignited, it disappeared. So let's try that one more time. We're gonna put a little bit more butane in the bottom of our container. I'm gonna get a new match. I'm going to put my safety equipment on, my headgear down, light my match. Oh, I broke my match. Let's try another one. There we go. Grab my butane bubbles and light it up.
Light it up.
And just like that, I can catch my hand on fire in a safe manner. Again, don't try this one at home. I'm a trained professional, but that's one of my favorite fire experiments of all time. And that's all of our experiments today. I hope you enjoyed joining me, Science North, in celebrating Canada Day in style. Be sure to tune in at 2 p.m. where the Community Arts and Heritage Education Program will be showing you 5 different art projects that you can try out. Be sure to also like Thunder Bay Events and Culture on Facebook, and shout out to Ontario Power Generation for supporting this event. Have a happy and healthy Canada Day, Thunder Bay.